Hi, in this tutorial I'm going to cover some examples of the binomial distribution. Let's start with an example. Let's say that a student is taking a multiple choice test in which there are 4 questions, and in each question there are 5 different answers. We want to know what's the probability of guessing 3 correct answers out of the 4 questions. Now, for each question we know that we have 4 wrong answers and 1 correct answer. Let's suppose that the first question of the test is, where is Toronto located? And the 5 different answers are Italy, Spain, Belgium, Canada, Germany. So for this question, the probability of guessing the correct answer is 1/5, because the question has 5 answers and only one of them is correct. So the probability of guessing the correct answer is 1 divided by 5, which is 0.2 or 20%. But what's the probability of getting the wrong answer then? Considering that we know that there are 4 wrong answers, we can easily conclude that the probability of getting the wrong answer is 4/5, which is 0.8, or in other words, it's 1 minus the probability of guessing the correct answer, which is 1 minus 0.2, giving the result of 0.8 or 80%. Now, this was easy, but let's go back to the original question. We want to know the probability of guessing 3 correct answers out of the 4 questions, and we know that each question has 5 answers, where only one of them is correct. We can resolve this problem by using the binomial distribution in Minitab, because all the requirements for the binomial distribution are met. Let's review them. 1. In a binomial distribution, there must be a fixed number of observations, and we are meeting this requirement because there are 4 questions in the test. 2. In a binomial distribution, the trials have to be independent, and we are meeting this requirement as well because each question in the test is independent of the other questions, or in other words, the answer of one question will not influence the answer of another question. 3. In a binomial distribution, each trial outcome must go into 2 categories, usually called success or failure, correct or incorrect, and so on. In our example, the answer of the question will be correct or wrong. There is no third choice. And 4. In a binomial distribution, the probability must remain constant for each trial. And in our example, all the questions have 4 wrong answers and 1 correct. So, the 20% probability of guessing the correct answer is the same for the questions in the test. Now that we know that we have met all the requirements, let's see how to do it in Minitab. You click on Graph and you select Probability Distribution Plot. Then you select View Probability. When you click OK, Minitab is suggesting the normal distribution by default. We select the binomial distribution and we need to fill in the values related to the number of trials and the event probability. So in the question we know that we have 4 different questions, so the number of trials it's 4, while the event probability is the probability that the incorrect answer will occur, and we have just calculated that it's 1/5, and then we enter 0.2. Now when you click on shaded area, we want to know what's the probability of getting 3 correct answers out of the 4 questions. So we need to understand what's the probability related to a specific value. So for this reason we click on X value, which will be 3, because we want to know the probability of 3 correct answers out of the 4 questions. And being a fixed value, a specific value, we click on middle, and if it was a range then we would enter the range in these 2 boxes, but being a specific value we just enter 3 and 3 in both boxes. When you click OK, you can see that Minitab is telling us that the probability of getting 3 correct answers is 0.0256. Let's see another example. The question is, based on historical data, we know that in a transaction there is 1% probability of making an error. Every day we process 150 transactions. We want to know the probability of no errors, 1 or more errors, exactly one error, two or more errors. Let's do it in Minitab. So we click on Graph, Probability Distribution, View Probability. Then we select Binomial. The number of trials is 150, and the event probability it's 0.01, because we know that there is 1% possibility of making an error, and we process 150 transactions every day. Then we click on Shaded Area, X value, and considering that we want to know the probability of making no errors, so we're talking about a specific value, so we're not talking about a range, so we click on Middle, and we fill in the two boxes with 0 and 0. When you click OK, you can see that the output is a chart, a bar chart in which we have 22% of the probability of making no errors. Now let's go to the second part of the problem. We want to know what's the probability of making one or more errors. So again, we're going to Graph, Probability Distribution, View Probability. We click OK. So the values are still there from the previous exercise. So we go into Shaded Area. This time we want to see the probability of one or more errors. So we need to look at the right tail, and we enter the value, which is 1. So that's the output would be for one or more errors. When we click OK, we can see that the output is 77% of the probabilities. The third part of the exercise, it's what's the probability of making exactly one error. So we go into Graph, Probability Distribution Plot, View Probability. Okay. Shaded Area. So we want a specific value. It's only one error. So again, we click on Middle and we fill in the two boxes with 1 and 1. When we click OK, we can see that the probability is 33%, 0.3355. And the last part of the exercise, it's what's the probability of making two or more errors. We can recall the dialog box by clicking this icon here, and then we go into Shaded Area, and this time we need to look at the right tail again, so that we can have the values from 2 and more errors. So when we click OK, the output is 44%, 0.4430. And that's all. Thank you for watching. Bye.